Chapter 2: The Physical Layer. This chapter we will cover theoretical basis of data communications, guided transmission media, wireless transmissions, communication satellites, digital modulation and multiplexing, public switch telephone network, mobile systems, and cable television. The most important part is that you have to understand what the physical layer does, which is part of the OSI model. It is the foundation on which other layers are built on. Some of the properties include the wires, fiber, wireless, that limit to what the network can do. Key problems is to send digital bits using only analog signals, which is called modulation. Some theoretical bases of data communication that are fundamental, and there are limits. The Fourier analysis, bandwidth limited signals, and the maximum data transfer channel that we will go over in a second. The Fourier analysis is a time-varying signal that can be the equivalent represented as a series of frequency components, such things as harmonics, and you can see by the graphs an example of the bandwidth limited signals. They're basically having less bandwidth and degrades the signal. You can tell that you will actually have less bandwidth, but then they actually degrading the signal. That means that you have some lost packets. And then you have the maximum data rate of channel. Nyquist theorem relates that the data rate to the bandwidth, which is B, and the number of signals, which is B. These are fundamental limits, and real systems can only approach them. Sn is called the signal-to-noise ratio, which is NSR, and is commonly measured in decibels on a logarithmic scale of 10 dB. Means the signal is 10 times the noise. 20 dB means 100 times the noise. Guided transmission, wires and fiber. Media, they have different properties, and of course their performance is hence. You got reality check, storage media, then you got wires. You got different types: twisted pair, coaxial cable, power lines, and then of course you got fiber cable, which is now very popular nowadays. Okay, so for example, we have a reality check of storage media. You send data on a tape, disc, or DVD for a high bandwidth link. Okay, and that can be a mail, one box with 1,800 gig tapes, as an example. Or it could take 1 day to send, where the data range can be from 70 gigabits per second. Data rate is faster than long-distance network, but the message delay is very poor. Some types of cabling, which is the physical side. Okay, you got twisted pair, okay, which is very common now, especially for LANs, which is local area networks, and telephone lines. It does reduce the radiated signal, the interference. Okay, that what you see is an example of a Category 5 UTP cable. This is the garden variety cable used in most offices. As a gigabit Ethernet cable, it is also the old-fashioned telephone line that reaches into your home. The twist reduces interference because of the signal radiated from a wire at one location is largely cancelled by the signal from the nearby twist. Tighter twisting gives higher quality wires. UTP, unshielded twisted pair, and STP, which is shielded twisted pair, does not exist to shield the wire from the external noise. For more demanding uses, higher data rates, but it is more expensive and difficult to work with. Some terminology: you got full duplex link, which is used for transmissions in both directions at once. That means that you got stuff going back and forth. Half duplex is both directions but not at the same time. And then you got simplex, which is only one fixed direction at all times but not common. You also have some wires, which is the coax wiring system. Okay, it is also common but better shielding and more bandwidth for longer distances and higher rates than twisted pair. The higher quality cable than UTP that can carry data at a higher rate for longer distances but is usually more expensive to do. Enclosing one wire with another provides better immunity to electrical noise, commonly used for videos, cable TV because it needs a larger bandwidth. Wires, power lines. Household electrical wiring is another example of wires. It's convenient to use but horrible for sending data. It is horrible because it carries power signals at the same time and the wiring was not designed for data communication. For example, it is not tightly twisted like twisted pair, and its electrical properties change as devices that are plugged in turn on and off. But it is convenient because it is already installed in many devices or plugged in to get power. Some people are starting to use it nowadays. Then we move into fiber cables. Fiber cables are becoming more and more popular but expensive. Common high rates and long distances. For example, you got some internet service providers who use it, fiber to the home, light carried, and very long, thin strand of glass. You have to be careful sometimes because if you actually don't know how to work with cables, you might have some issues. The other main kind of guided media is the optical fiber. It is widely used for links that run at a high rate, particularly over long distances. It is much better than wire in both regards. Examples include the backbone links between ISP, Internet Service Provider facilities, and fiber runs to the home that provides much higher bandwidth home connectivity than a DSL connection. The optical fiber is very long, thin strand of glass. The figure shows the above overall system. Okay? A light source is needed to produce pulses of light, either a LED or a laser, okay, which is better quality but is more expensive. The pulses of light are trapped in the fiber, total internal reflection, and follow it. At the other end of the photodetector turns pulses of light into electrical signals, and that's how you actually get connected. Also, it has enormous bandwidth and tiny signal loss, which is good, but it's expensive. Okay, so the slideshow right that you see here, this image shows why fiber runs for high rates in long distances. Attenuation is very low, that can go 10 kilometers before the signal has lost 3 dB or half of its power. For enormous regions of bandwidth, 30 terahertz, not gigahertz, terahertz, when wavelength is converted to frequency. Here you have an example of single mode and multi-mode. Single mode is, of course, is narrow, light, and can even bounce around. It's used with lasers for long distances, where multi-mode is the main type of fiber that's light and can bounce, but is used with LED for cheaper, shorter distance links. And you see an example there. Okay, comparison of properties of wires and fiber. We have, for example, the property fiber gives you very high rates over long runs. Wires score less highly on these properties and support high rates over much shorter runs. But wires are usually the inexpensive solution when the transmission reception hardware is included. Wires are also easier to work with. Fiber requires greater care with connections. Fiber has the advantage that it is very hard to tap as the light is confined only to the fiber or the fiber is broken. Wires are usually easy to tap because they radiate the signal well. You got wireless transmissions as well. They have different types. You got electromagnetic, radio, microwave, light, and wireless versus wired. Electromagnetic spectrum, different bands that have different uses. For example, you got the radio for wide area broadcast, 3G, 4G, LANs, okay, infrared. Okay, here's an example, okay, on how to, for example, for TV, cellular satellite frequencies that are heavily regulated, depending on the megahertz and gigahertz. Fortunately, they are only unlicensed ISM bands, okay? So for you got a Wi-Fi, but they're not cellular. They're free to use at a lower power device manage interference, widely used for networking, Wi-Fi, Bluetooth, and etc. Radio transmission. Okay, it's radio signals that penetrate buildings well and propagate through long distances with path loss. Okay, the path loss makes the signal fall for at least as fast as 1 day/2 due to the RF energy being spread out into a greater region. Okay, as you can tell, this is pretty much a technology that is even used for space exploration. Microwave transmission. Microwaves have much bandwidth and are widely used indoors and outdoors. Wi-Fi 3G. The signal is attenuated and reflected everyday objects. Okay. The variation in signal strength as the sender receives more is a key hallmark of wireless. It means that the data rates over wireless lengths can change dramatically and they are not fixed like a wired. Then you got lighter transmission, okay, which is not fiber, that can be used for links. Light is highly directional, has more bandwidth, and it uses LED cameras and lasers for photo detectors, and you can see an example right there. Wireless versus wires. Easy and inexpensive to deploy for wireless, naturally supports mobility, broadcasting, transmission interference, and we got wires with fiber. Easy to engineer and fix data rate over points, can be very expensive to deploy, and it doesn't really support mobility or broadcasting. Communication satellites are effective for broadcast distributions of anywhere, anytime communications. We're going to look at the different kinds of satellites. Then you got the geostationary, low Earth orbit, and satellites versus fiber. Satellites and their properties may vary by altitude. For example, you got the geostationary, medium Earth orbit, and the low Earth orbit. Okay, and that's basically the altitude. MEO is used for navigation systems such as the GPS, which everybody has in their vehicles, or most likely nowadays, everybody pretty much uses a GPS. The geostationary satellite is an orbit which is 35 kilometers above a fixed location. Okay, you can communicate with the help of a hub, and there's different types of bands in the gigahertz that are used but not be crowded by super specific terrain. The low orbit satellite systems such as Iridium use many low latency satellites for coverage and route communications via them. Since satellites are LEO, it doesn't take a long for signal from the Earth to go up and down and compare to the geo sites. Satellite versus fiber satellite can rapidly set up anywhere, anytime communications can broadcast to larger regions, but the bandwidth is limited, unfortunately. With fiber, enormous bandwidth over long distances, but the installation can be more expensive and difficult. Digital modulation and multiplexing. Modulation schemes can send bits as signals, where multiplexing can share a channel among users. Baseline transmission, lines of codes that send symbols that represent one or more bits, NRZ in the simplest. Then you got the clock recovery, which is the decoding. Strategies go from simplest to more complex and make progressive better use of bandwidth. Manchester is a simple, every symbol that has embedded transmission but uses twice the bandwidth of the data signal. 4B and 5B ensures that no more than 3 zeros in a row. Ones can be handled by making the signal level change to represent a 1 and needs 1.25 times the bandwidth. A scrambler needs no extra bandwidth, just the data XOR sequence, okay, but only makes long runs of zeros and ones at a low probability event. Passband transmission is modulating the amplitude frequency phase of a carrier signal sent bits in a non-zero frequency range. Constellation diagrams are shorthanded to capture the amplitude of the phase of modulation symbols, as you can see some examples there. In gray, coding assigns bits to symbols so that a small symbol error causes a few errors. Frequency division multiplexing. FMD, which is frequency division multiplexing, shares the channel by placing users on a different frequency. As you can tell right there, that is actually sharing channel 1, 2, and 3 in the same frequency. An orthogonal FMD is an efficient FMD technique used for 802.11. I hope everybody knows what 802.11 is. 4G cellular and other communications. Time division multiplexing is time division that shares a channel over a time. Users take turns on a fixed schedule. This is not a packet switching and is widely used in telephone or cellular systems. Code division multiple access. CDMA shares the channel by giving users a code. Codes are orthogonal and can be sent at the same time, widely used as part of the 3G network. This is very important. For example, a lot of times when you travel overseas and they tell you CDMA, no CDMA, what type of technology does your phone use, this is where they're actually coming back to. Public switch telephone network. The structure of the telephone system is a hierarchy system for carrying voice calls made up of local loops, mostly analog, twisted pairs of two houses, trunks, digital fiber optic calls, and switching offices. As you can tell, there's an example of when the telephone and how it actually processes everything to the other phone. The politics of telephones. In the US, there is a distinction for competition between serving a local area and connecting to a local area to switch calls across areas. This distinction is to encourage competition by splitting the local and long-distance markets. Another regulation to promote competition is local number portability. You can take your telephone number when you change carriers to make the changing easier. Telephone modems, both technology, sends digital data over a 3.2 kilobyte analog voice channel. Okay? Rates are 56 kilobytes per second or less. This used to be like dial-up connection, okay? Now has been replaced by faster connection. Digital subscriber lines, local loop, DSL broadband, sends data over a local loop to the local office using frequencies that are not used by pods. Telephone computers attached to the same old line. A DSL for asymmetric DSL is the most popular version of DSL. The asymmetric means that the greater bandwidth, hence greater data rates, are allocated in the downstream traffic. Fiber to home. Okay, basically it's a broadband that relies on the deployment of fiber optic cables to provide high data rates to customers. Okay, and fiber is passive. Trunks and multiplexing. Calls are carried digitally on PSTN trunks. A call for an 8-bit PCM sample, each 125. A SONET synchronous optical network is a worldwide standard for carrying digital signals on optical trunks. Here's an example. Okay, WDM, another name for FMD, which I hope you still remember what that is used to carry many signals on one fiber. And there's an example. You got 1, 2, 3, 4 fibers going through the same one. And how it is filtered. Switching uses circuit switches. The internet uses packet switching. Okay, just the difference between those two. Circuit switching requires call setup, which is connection before data flows smoothly, where packet switching threads matches independently, no setup but variable queuing. Comparison of circuit and packet switch networks. Okay, there's your item compared to a circuit switch and a packet switch. You can tell the difference between the two, voice and data. Mobile telephone systems. 1G, analog voice. The 1980s, mostly radio. 2G, analog voice and digital data in the 1990s, GSM technology, remember that? 3G, digital voice and data in the 2000s, and now we're at 4G, which is data included voice, okay, which is deployed in the 2010s. I think that was a mistake, okay? I'm sorry, not that 4G was a mistake, but I mean, I think the 2010s, I think was a little bit later than that. Cellular mobile phone systems, all based off notion of spatial regions called cells. Each mobile uses a frequency in a cell, and then basically does the handoff. Frequencies are reused across non-adjacent cells. Global system for mobile communications. Mobile is divided into handset and SIM card. Subscribers, mobiles tell their age, their home relocation to register whereabouts of incoming calls. And there's an example. Basically, if you go to like different service providers, it will automatically register with network. Error interface is based on FND channels at 200 kHz, okay, and the mobiles assign up and down the stream. There's an example. Universal Mobile Telecommunication Systems and architecture and evolution of GSM, terminology for packets to and from the internet via different types of technologies, and that's why whenever you go overseas, if your GSM phone ready, you will connect. The other one is the CDMA. Cable television, internet over cable, which is very common nowadays. Internet over cable reuses the cable television plant. Data is sent to on the shared cable tree from the DSL. There's an example. You got internet service provider sharing through fiber the connection. The spectrum allocation is upstream and downstream data allocated in the frequency channels. Cable modems. Cable modems inside customer premises implement the physical layer that basically allows you for the upstream and the downstream. Cable versus ADSL. Cable uses coax cable, broadcast to all customers, and the bandwidth is shared. DSL bandwidth is dedicated to each customer point to point and uses twisted pair. Please go ahead and make sure you do the discussions for chapter 2. There are 2. And make sure you do the first assignment, which is the theoretical, and then you do the second assignment, which is the practical. Okay? Your active participation, it is required, and please make sure that the assignments are turned in on time, otherwise your grade will be affected. Thank you.